Hello and welcome to Digital Systems 2. This is week 1, lab 2, and what we're going to be looking at is a frequency divider. So I went ahead and built the circuit for you. This is the circuit that you have in your lab handout. I did all the connections so you can see how everything is supposed to go. Let me zoom out just a little bit. There we go. Hopefully you can still see that on your screen so that you can draw these things on your own. Now, what the lab is going to ask you to do is go ahead and modify the frequency, the input frequency here, and then start off from something like 1,000, go down to 500, 150, and just kind of see what's happening with the circuit. I'm not going to go through all those little steps for you. I'm just going to kind of do the last part, but I'm going to do the last part with the first circuit. So there's two configurations of the circuit. And the first configuration in the first couple of steps, you'll notice that the Q0 output here on pin 14, let me go ahead and zoom in right here, right? So the Q0 is actually feeding the clock of the second circuit, right? So over here, pin 10, Q0 is feeding the clock here, pin 14 is feeding the clock there, and so forth. And it just goes on and on and on. What you're going to be required to do for the second part is not drive the clock of the second chip by the Q0. It's going to ask you to change it to Q, and that's the only thing you're going to do in the second part of the circuit to see what happens with the counter. Is it counting up or is it counting down? That's the kind of things you need to figure out as you run the circuit and answer the questions. But I'm going to go ahead and do a quick demonstration for you so you know what to be looking for. I went ahead and wired up your logic analyzer so you see how that works. Hold on, let me see if I can move that up. Okay. And I wish I could move this whole thing over, but there's no way to do that. Oh, and let's hide this little thing here. So I'm going to go ahead and run it. And you can see I have this at 50 hertz, and 50 hertz is a good signal because you can actually see it change. I go any faster, it's really hard to tell. And excuse me. I apologize for that throat clearing there. Okay, so let's go ahead and do that. Do this, and let me just change it to 100. And then I'll go ahead and jump to something like 500, and you'll see the difference. Oops, you can't do that while it's running. Okay. Oh, there it goes. Notice that the frequency is changing the counter here, and you can tell whether it's going up or down. If you actually can't tell, just lower the frequency low enough till you see it happening. And if I were to do something like, I'm just going to jump to 1,000. All right. And that is really hard to tell which way it's going. You wouldn't be able to tell at that high frequency. But again, that's just one of the questions they're asking you. And hold on, need some water there. Yeah, so if you can't tell, just go ahead and lower the frequency. But let's go back down to, well, let me keep this at 1,000. And now let's look at what's happening at the actual frequencies of the output of each stage. So in this case, let's say we start off at 1,000 hertz. We should be dividing the frequency at the first 74 LS76 flip-flop by 2. So we should be getting about 500 here. And then that feeds the next cycle. So we should be getting about 250 there and so forth, 125. So let's open these up. Okay, I put that one. Oh, I got it the other way around. That one is 1. Okay. 2. Okay, I previously put these in this order, so they popped up back in the same order. But notice that right, if I start off with 1,000, I'm going to go ahead and run it. You'll see that out of the first chip is the clock cycle drops down to 500. The second one, it drops down even further to 250, because remember that this clock of the 500 is feeding the second chip. That's being divided by 2, which gives me 250, and so forth. Divided one more time by 2, 125, and one more time by 2 is 62.5. But they want us to, just tell what's happening with the clock. And I said, go ahead and keep this at 50. 50 is a good frequency that allows you to actually see the change. So let's go ahead and run this. Okay, now you can see the numbers moving up slowly. But again, go ahead and look at the side of the frequency counter. You can see the frequency changing, again, starting off with 25 hertz, which is half of 50, and then divide that by half is 12.5, divide that by half is 6.25, and divide that by half is 3.125. Now, the last part of this lab is asking you to actually do use a logic analyzer to visualize all the inputs and see what's happening on the logic analyzer. So you can see I hooked up the clock right here to the clock input, so we can see what that is. And then I hooked up all the other outputs. The first two pins, I hooked it up to the Q and Q naught. The instructions tell you to do that. So I'm looking at the Q and Q naught for the first chip, and then the Q and Q naught for the second chip. So I just go straight down in order. Again, the third chip, Q and Q naught, is on the next two inputs, and then the last chip, Q and Q naught, goes down to the very last chip. So let me just double click this, and hopefully it's not in the way. Let me just put it up there somewhere. And what you can see visually here is that the clock pulse is moving, right? In this case, it's going to be, what are we at? 50 hertz. 50 hertz. And of course, the outputs of Q and Q naught, which is here pin 2 and 8 for the U4A, right? That is half the frequency of the clock pulse, so it's a little bit slower. And since it's Q and Q naught, they're in opposite directions, right? So when Q is high, Q naught is low, and vice versa. When Q is low, Q naught is high. So they should be mirror images of each other. But then go and look at the output of the U4B, and we'll see that's actually pin 1 and 6 here. And so notice that the frequency is even longer for it to shift. And again, Q and Q naught should always be opposing each other, like a mirror image there. And then out of the third chip, notice that it's even longer, so the frequency is divided one more time. And then on the last chip, it should be the longest. Right? So that's what they're asking you to do in this lab, so you can observe that. What they're going to ask you to do in the lab is actually, so I have this set up for the first configuration of the circuit. What they're going to ask you to do is not use the output of the Q naught to run the clock of the next circuit. It's going to ask you to run the Q into the input of the clock of the second circuit. So all you're doing is changing Q naught to Q to go to the input of the clock. So in other words, get rid of that clock connection there to Q naught and then connect it to Q and do the same thing. Again, the image is in the handout, so you can do that in the handout. What you're going to notice if you do Q as the input to the clock versus Q naught, they're asking you the question, what changes, right? So you should see a very similar signal here. It's not going to change the frequency divider function. Right. So if we just switch the clock input from Q naught to Q, all we're doing is changing, say, the phase at which point it goes up and goes down, but the frequency divider is still going to be exactly the same. You should still see these same frequencies: 25 hertz, 12.5, 6.25, and 3.125. But I want you to let me know, will that change the direction that the clock is counting? I won't answer that question, but I want you to tell me. All right, so this is how it's all wired up. Let me just move this down a little bit there so you can see my 5 volts is up there. And that is all you need to know for the second lab. Again, week 1, lab 2. I think your lab is labeled as, let me go up here real quick. If you go by the module, yeah, it'll say lab 2 on the handout. Yeah, so I'm going to go, when I'm making these videos, I'm going to be referring to the lab as they are written on the handout, not as they are written on the lab module within Canvas. Okay, that's it. I want to thank you very much for your time. And that concludes our lab videos for the week.